All right, now let's talk about doing some calculations with IV fluids. There's three basic types of calculations we're going to do. Calculating milliliters per hour infusion rate, calculating drops per minute infusion rate, and then also calculating total infusion time. So often that first one is kind of the simplest and usually just requires some simple division. So if a doctor orders 1,250 milliliters of IV solution to infuse in 10 hours, what is the milliliter per hour infusion rate? So we're just going to take the volume and divide it by the time ordered, right? The volume ordered divided by the time ordered, and that's just a simple fraction, 1,250 milliliters per 10 hours. And we see why we're going to end up with milliliters per hour just by following the units that we have here. So 1,250 divided by 10 is 125 milliliters per hour. Sometimes there's a little bit more to do here. A doctor orders 500 milliliters of IV solution with 25,000 units of medication in it to infuse at 1,000 units per hour, and we want the milliliter per hour flow rate. So here's the thing. It seems like there's a couple parts to this order, right? We have the how many units of the medication in 500 milliliters, and then this rate. But like the important part of this is that this medication has to infuse at 1,000 units per hour. So I'm going to start there. Think of that as my order. This other part of the order actually gives us an equivalence. So it tells us that 500 milliliters is equivalent to 25,000 units. And we want milliliters per hour flow rate. So look at where we're starting here. We've got 1,000 units per hour. The units I want are milliliters per hour, so I'm not going to do anything to get rid of those hours. I like that I have those hours on the bottom. That's where I want them to be. But I basically just want to convert units to milliliters. And I can do that using this fact here. So 25,000 units to 500 milliliters. The units cancel. I'm left with milliliters on top and hours on the bottom. That's what I wanted. So 1,000 times 500 divided by 25,000 is 20 milliliters per hour. All right, so we're going to now look at some calculations where we're finding drops per minute. So first, we abbreviate drops with GTT, and we need to know the drop factor of, which is specific to a situation, right? So the drop former, or the hole in the drip chamber, maybe it's going to make big fat drops, and so there are very few drops to make up a whole milliliter, or maybe it makes super tiny drops and it takes lots of drops to make up a milliliter. And that's basically what the drop factor tells us. It's kind of a sense of how big the drops are. We always round drops per minute to the nearest whole number because we can't have a fraction of a drop. Something is either dripped or it hasn't. So we're going to round these values to the nearest whole number. Let's do an example. A doctor orders 1,000 milliliters of IV solution to be infused in 10 hours. The drop factor is 10. So when they say the drop factor is 10, what they're telling us is that it takes 10 drops to make a milliliter. 10 drops is equal to 1 milliliter. And we want to end up with the flow rate of the drops per minute that the IV should be set at. So we know they gave us information right at the beginning to get the milliliter per hour infusion rate. So I could take 1,000 milliliters divided by 10 hours. That'll give me, if I stop there, milliliters per hour. But I want drops per minute. So I know that there's, in 1 milliliter, 10 drops. So I'm going to start there. I have to put the milliliters on the bottom to get those to cancel. Now if I stopped here, I would have drops per hour. That's not what we want, but we just have one more equivalence to use to get to hours to minutes. 1 hour is, of course, 60 minutes. We're left with drops per minute. So 100, let's see, these 10s will cancel, I guess. We could do the whole thing on the calculator, but it's kind of simple to cancel this 10, so we're going to have 1,000 divided by 60. So 16.67 drops per minute. And then I have to remember, okay, look, a drop, I'm not going to have a fraction of a drop. It's either dropped or it hasn't. So I'm going to round this to the nearest whole number. So I take a look at this digit right there, which is, if it's greater than or equal to 5, which it is, I'm going to round up. So 17 drops per minute. Let's do another one. A doctor orders 500 milliliters of IV fluid containing 2 grams of medication to infuse at 2 milligrams per minute. They gave us the drop factor, 60 drops per milliliter, and we want to know the drop per minute flow rate. So there's a lot going on here. There's sort of 2 parts to the doctor's order. We have the 2 grams of medication in 500 milliliters of fluid, and then it's supposed to infuse at 2 milligrams per minute, and we want the drop per minute flow rate. So here's one thing that's really important here. We're finding a flow rate. We're finding a rate. And I often think of these problems in a way like, if I want to find a rate, I'm going to start with a known rate. The known rate they gave me is 2 milligrams per minute. So I'm going to sort of treat that as my starting part of the order. And then this part of the order gives me an equivalence. So 500 milliliters is equivalent to 2 grams. And then the drop factor is 60 drops per milliliter. So I know that 1 milliliter is equal to 60 drops. And we want to end up with drops per minute. So I'm going to start with 2 milligrams per minute. I want to get to drops per minute, so I'm very excited about the fact that I've already got minutes on the bottom. I'm not going to do anything to get rid of those minutes. I'm basically going to want to convert milligrams to drops in this scenario. So since I've got milligrams, this is where I'm going to, really, the only place I can go here is find a way to use this given information here that I've got 2 grams in 500 milliliters. So first I'm just going to convert from milligrams to grams. There are 1,000 milligrams to a gram. Now I can use what I have on hand here, 2 grams, equivalent to 500 milliliters. Let's see where we're at with the units right now. Milligrams with milligrams, grams with grams. Now if I stop here I'd have milliliters per minute, but I want drops per minute. So now I'm going to use the drop factor. 1 milliliter, which has to go on the bottom to get those milliliters to cancel. 1 milliliter, 60 drops. Now, cancel the milliliters. I'm left with drops per minute. That's what I wanted. So we have 2 divided by 1,000 times 500 divided by 2 times 60, I get 30. Came out even, so I didn't have to round. 30 drops per minute. Okay. Now, our last type of calculation is finding the total infusion time. Maybe I know what rate something's going at, and I know how much they're going to get. So I just want to know, like, what's the total time? Like, how much time will it take for all of this to infuse? So here, doctor orders 2,500 milliliters to infuse at 20 drops per minute, and the drop factor is 15. We want to know how long will it take the IV to infuse. So a couple things. First, they tell us the drop factor is 15, so I know that 1 milliliter is 15 drops. I'm just going to write that down. Now, I want total time. So if I'm computing total time, I'm not finding a rate. I'm not starting with a rate to end up with a rate. I'm finding total infusion time. So what I'm going to do is take the total volume and try to convert that to total time. So the order that I'm going to start with like my starting point, is that total volume of 2,500 milliliters. The other part of the order, 20 drops per minute, I'm going to use that as an equivalent, that 1 minute is equal to 20 drops. So I take this total volume, and I want to get to total time. Now I've got milliliters here, and there's only one opportunity for me to cancel out milliliters. It's this drop factor. So I've got to put the milliliters on the bottom, equal to 15 drops. Now if I stopped here, I would figure out how many total drops are going to infuse. And, you know, maybe that's an interesting value to find, but maybe not entirely useful. So from drops, now I can use this drop factor, 20 drops per minute, 20 drops equivalent to 1 minute. This will give me the total number of minutes. Now let's say, let's find the total number of minutes here. So I have 2,500 times 15 divided by 20. I get 1875. Now usually if I want total time, I want to find it in hours and minutes, right? 1,875 minutes, maybe not super helpful. So if I take, I'm going to figure out how many whole hours are in there. So 60 minutes to 1 hour. I get 31.25 hours. So this is 31 hours and then so many minutes. So what I could do is take the 0.25 hours and figure out how many hours. Now it's a quarter of an hour, right? 0.25. So we could just sort of mentally say, okay, that's going to be 15 minutes. But if it were like some other weird kind of decimal part that we just couldn't do mentally, all I would need to do is take that decimal part, 0.25, and then convert it back to minutes. So I take 0.25 multiplied by 60, and of course that gives us 15 minutes. Okay, one more. A doctor orders 250 milliliters of IV fluid to infuse at 22 drops per minute. The drop factor is 60, and we want the total infusion time. So the drop factor is 60 means 1 milliliter is 60 drops. So this makes super tiny drops. We want the total infusion time, and we know the total volume, 250 milliliters. So I'm going to start with total volume. I want total time. We know the rate that it's infusing as 22 drops per minute, so that means that 1 minute is equivalent to 22 drops. Now if I'm at milliliters, really the only place to go from here is the drop, to use that drop factor. 1 milliliter is equivalent to 60 drops. And now that I'm at drops, I can get to minutes. 22 drops is equal to 1 minute. So let's see where this lands us. Milliliters cancel, drops cancel, left with minutes. Divided by 22. 681.81 point, I guess I should call that 82. I'm rounding to the nearest minute. So let's see how many hours we have. And I'll just keep this value in and divide it by 60 automatically because it recalls that value. We have 11.36 hours. So now this is one of those times where I'm really going to need to use this technique up here to convert. So I've got 11 hours and so many minutes. So I'm going to take this 0.36 hours to figure out how many minutes. So 0.36 times 60. 21.6, I'll round that to the nearest minute. We'll call that 22 minutes.